So solving systems of equations by graphing. First of all, let's just kind of talk this through. When you see the word system, then you should be thinking like things that go together in order to create an outcome, right? When we say a stereo system, you have speakers, you have an amplifier, you have the actual um, kind of the tuner piece of that, right? It all goes together to create one solid output on what they do. Or let's say like a computer system, it's the monitor, it's the keyboard, it's the processor, it's all that to go together. So the word system means multiple components coming together to give an outcome, right? So we're trying to solve systems by graphing. So what we have here is a couple different equations, and I want to know what is the one outcome that these two things share or have in common that come together. So we're going to do this by graphing. Now these things, I've set them up so that they're all in slope-intercept form. So we're going to start there. So let's do this one in blue. That way you can kind of see it. I'll do the next one in a different color, and then we'll kind of capture that. So here's the first one. Remember how to graph in slope-intercept form. Go to the intercept, -1. Okay, put a dot there. And then look at the slope, right? That's the number that's hanging out right in front of the x. That's why slope-intercept form is so good for us. And I'm going to put the negative. I'm just going to attach it to the top on most of these. So down 1, over 1, 2, 3. Okay, now let's put a nice line through here. Right, looks like it's doing that, like this. Right? I mean, my lines aren't great and straight. That would be nice if they were. Definitely makes this a lot easier to do. Okay, let's do this next one in green, right? So I'm going to do this one in green just so you can see the difference in it. So I'm going to look at it says go down to -4. Okay, put a big dot. And then its slope right here is 2, 3. They're both positive, so I'm going to go up 2 over 1, 2, 3. Bam. Going to see that right there. So what I'm going to do, I got these two equations here, and what I'm trying to do is figure out where do they intersect. There's where they intersect. Well, what is that point called? Well, it looks like we move 3 on the x, and then I drop down -2 on the y. This is the answer. So, I mean, another way to write it is x equals 3, y equals -2, right? So that is solving by graphing. We're trying to find out where do they cross. Now, if you wanted to, you should be able to plug these in. So I plug in -2 for y, -1/3, 3 for x, -1. Then I get -2 equals -1 minus 1. -2 equals -2. Guess what? It does equal -2. Let's try it in the next one. Let's go -2 equals 2/3 times 3 minus 4. So just plug in x and y. -2 equals 2 minus 4. -2 equals -2. Yeah, it works for both of them. So that's good. All right. That's a confirmation we have the right point right there. All right. So that's what it looks like right there. Let's do another one. Why not? Looks fun. Let's do this one in blue. All right, let's go first one. It looks like we got a -3, put a point. It says -7. Okay, here is where I'm going to change something right here. Instead of the -7 being on the top, I'm going to change it so it looks like this. Y equals 7 over -1x minus 3. So you can put that negative on the top and the bottom. Since it's a whole number, just put it over 1. And then I just change it so it looks like this. So then I can go up 1, 2, 3, 4, 5, 6, 7. And then -1 goes backwards 1. Okay, that would be my point. The reason I would have run out of graph if I would have done it the other way. Right? So this we know it's going to look something like this right there. Right, so if I did this the other way, down 1, 2, 3, 4, 5, 6, 7, and then over 1, I mean, it's still going to work, but it's off the graph, and I'd rather try to stay on the graph. So I just modified it so I could stay on the graph. Okay, let's try this one right here. -x plus 3. So I'm going to go up to +3, put a big dot, and then -x, -1 over 1. Remember, that's what that is. So go down 1, and then go over 1. down 1, over 1. You could do this for days, down 1, over 1, down 1, over 1. If you want to, go the other direction. Go upwards, backwards 1, upwards, backwards 1, right? So we could do that. But there is my line right there. So we're drawing that. What are we looking for? Intersection point. There it is. Where is that point if I were to name it? -1, and it looks like we're up to 4. -1, 4. That's it. We could plug it in. We could check it. We could rewrite it if we need to. X equals -1, y equals 4. Right? That works. There's a system equation. We just solved systems by graphing them, right? Getting them into the same graphs. Let's see if there's anything striking about any of these. I don't really see any. So these are all going to be the same thing. I'm going to do one more here. I'm jumping all the way to number 5 just to give you one more at it. But I would encourage you to do as many of these as you want. It's a great way to practice our graphing, but also just being able to just utilize the tools that you have and the strengths that you have here to graph these things. All right, 2. We got down 1 over 2. Down 1 over 2. Okay, there is, wow. There's my blue line. Let's go ahead and put a green line in here just so that you can see it. Obviously, you don't have to have different colors. You just kind of do them the way that you do them. -2. Now it says down 5 and over 2. 1, 2, 3, 4, 5 over 2. So that's going to put me off the graph. So I might want to change that so that negative is with the bottom instead. So let's try it that way. 1, 2, 3, 4, 5. Then we're going to go backwards 2. And we're going to be right there. So as I graph those lines, we are not very straight on these lines. But you get the point. I can see where they are trying to cross with my non-straight lines. Trying to cross right there. Where's that point? It is -2, +3. Done, right there, right? And we can always try those and check those. So that's what those look like right there. Ooh, here's some good ones right here. These are multiple choice. See down here, they're giving us a bunch of answers, and we're trying to figure out which of these answers is correct. So what can we do? Number 1, we can graph these two things and just see which point they cross at. Or if we just want to do a little guess and check, we can take each of these, take the first one, plug it in, see if it works. If it doesn't, then it's not working. Then you can take the next one, plug it in, see if it works. Right? It depends on what you're faster at doing. I feel like I can do these real quick. So I'm going to go to 2, up 1, over 1. I'm going to graph that, up 1, over 1. You can do downward, backwards 1, right? Those are all the same idea. So that would be real quick. The next one, -3, and it's got a 2, 3. I'm going to put the negative on the bottom, so I'm going to go up 1, 2, backwards 1, 2, 3. Oh, there it is. There it is. Right? I'm going to be right here. Well, what is that value? -3, -1. That's the one. A is the answer. There you go, right? Trying to graph on the same graph. A system of equation is literally, instead of doing what we did a couple chapters ago, just graph it. We did it last chapter. Just graph 2 graphs on the same graph, see where they cross, right? The only couple exceptions you would get is if I did a graph and then I drew my next one, whoa, and they never crossed. This would be an exception called no solution, right? So that happens sometimes. Sometimes we get ones where I graph and then I graph again, and it's 2 lines right on top of each other. This is an exception called all real values, or sometimes known as infinite solutions, right? So be on the lookout for these types of problems too. Most of them that you get will be 2 graphs that cross at one point. 2 graphs that cross at one point. And my goal here was to keep them so they cross real nicely and cleanly on the graph. So give it some practice. There's also 4 more on here that you could do for more practice and just see if they cross those nice, clean spaces.